with the COVID-19 pandemic still affecting us all the crucial to everything we are trying to do, stay safe. Wearing a mask is one of the simplest and the most effective ways to prevent the spread of the virus. It acts as a barrier stopping those teeny droplets of the getting into the air and infecting others. But sometimes we are forgot or don't wear in the properly. That's where technologies come in the handy. We can use the digital image processing to detect the whether people are wearing a mask correct in public spaces.
In our mass data research, we explained how we did things to the methodology part. First, we work on the pictures, making them better and clear. Then we use smart computer problem to pick out important details from those pictures. And after that, we taught the computer to tell if someone was wearing mask or not. We did this by showing it lot of pictures and telling it what each one was. Finally, we checked how good our computer was at the job at testing it with new pictures. We use number like accuracy and precision to see how well it did.
Okay. Hi, I am Shahan Indrajit. My index number HTC 23.1F001. Okay. Uh, I will explain the uh, codes of our mask detection system. Okay. So we get two Python codes. One is train mask detector for training the dataset, and detect mask video for the detect mask from webcam. Okay, so I will move with train mask detector. So first we import necessary libraries like TensorFlow for deep learning, uh, and other libraries for data pre-processing, model architecture, and evaluation and visualization. Okay, so in here, set initial parameters. I use init underscore lr for initial learning rate. Uh, focus for number of focus for training, batch size for training. This is the directory of path to this directory is a path to the dataset directory. Mm, in that dataset has two categories. One is mask with mask and without mask. Okay. In here we load and pre-processing images. Load images from the dataset directory and pre-process them, like resize, convert to array, and pre-process input. And yes, in here we prepare data, perform one hot encoding of the labels, and split the data into training and testing sets in this part. Okay. In here, data augmentation the data training to increase the diversity of images for better model generalization. Mm, uh, in here, we define model architecture, load MobileNet v2 as the base model without the top layers, uh, and add uh, add custom layers, uh, average pooling, flatten, dense, on top of the base model for classification. Uh, And here define the final model by specifying input and outputs. Here freeze base layers. Uh, freeze the weights of the base model to prevent them from being updated during the initial training. In here, compile the model with binary cross entropy loss and Adam optimizer. And in this part, uh, train the model on the training data using the data augmentation, validate mm, and validate the model on the testing data. Uh, right. Uh, and evaluate the model. Performance using classification report. In this part, and in here we save the model uh, as a H5 format, and this is plot training history. Visualize the training loss and accuracy of a focus, and save the plot and as an image. Okay, then we move into the detect mask video Python file. In here we also importing necessary libraries, including TensorFlow, OpenCV for computer vision tasks, and NumPy for numerical operations. Okay, in this function, detect and predict mask. This function takes a frame captured from a video stream, a pre-trained face detection model, FaceNet, and a pre-trained face mask detection model, MaskNet, as an input. Okay, it detects faces in the frame using the FaceNet model. It extracts each face pre-process and stores it in a list faces. It predicts whether each face is wearing a mask or not using the MaskNet model. This is a MaskNet. In here, I load MaskNet detect H5 model to the MaskNet. Okay. Here, I load the MaskNet. Video stream visualization in here. Initialization. Initialize the video stream using OpenCV video capture function. The index 0 indicates the default camera. And here in this area, this loop used for frame processing loop, continuously read frames from the video stream and resize each frame to a desired width and image height. Press each frame to the pass each frame to the detect and predict mask function to detect faces and predict whether they are wearing masks. And yeah, this area, the bounding boxes around detect faces and label them as mask or without mask. Sorry, no mask, based on the prediction. Display the process frame with bounding box and labels, and clean up. If the Q key is pressed, the loop breaks and the program cleans up by closing all OpenCV windows and realizing the video stream resources.
Okay, I am GSDSC 23.1005. I'm Pathum Rangana. Uh, we are doing a project application about face mask detection. So I'm here to do demonstration part about our project. So I'm going to our project path, and here I'm type CMD and type in Python space like that, and it marks video.py and press enter. um, that our project is running. Okay, now you can see there's I'm not wearing a face mask. So in this telling that no face masks 100% are detected. So you can see no face mask. So I'm going to now wearing a face mask. Now is detect as I'm wearing a face mask 199 like that percent. uh, so now I'm going to take off again. Okay, now I'm wearing again. Now okay, now you can see it says I'm not wearing a face mask like that. Okay, okay, control here. I'm finish our project. That's all our demonstration part. uh, Thank you.